Okay, welcome to Organic Chemistry Chapter 6. Alright, last week we spoke about the Part 1. This week we talk about Part 2, yeah? So Part 2, we're going to talk about aldehyde and ketones as well as carboxylic acid. These functional groups are very applicable to the food ingredients. Aldehyde and ketones are very applicable to the carbohydrates, whereas the carboxylic acid is very applicable to the fats and oil, yeah? Okay, let's look at the structure and bonding of the aldehyde and ketones. Okay, for aldehyde and ketones, both contain what we call the carbonyl group, C double bond O. Okay, carbonyl groups. Last week we spoke about the hydroxyl groups. Basically, that one is for alcohol. Okay, represented by O and H. For the aldehydes, okay, and the ketones, both they contains the carbonyl groups. The only difference, right, is basically the location of the carbonyl groups. For the aldehyde, is located at the end of the molecules, either end of the molecules, whereas for the ketones, the carbonyl groups is somewhere in the middle of the molecule. Examples of carbonyl groups molecules like the glucose. Glucose is one of the common aldehydes, okay, and you can see that the carbonyl groups is located at the end of the molecule, whereas the ketones, we have a very common one is the fructose. Fructose, you can see that the carbonyl groups is located at second carbons. All right, so this one is a ketones. For the molecules, you can see that the carbonyl groups they are separated around 120 degree between the three atoms here. All right. When you come to naming of the aldehyde and ketones, we use the IUPAC naming. The system is exactly the same. Okay, you still need to find for the longest chain, and then in this case we need to prioritize the carbonyl groups, and the carbonyl groups need to be the smallest number. For aldehyde, it's very straightforward because it's located at the end of the molecule, so it will be designated as carbon 1, 2, 3, 4. Okay, and the methyl group is located at carbon number 3, so 3-methylbutanol. Alright, so over here you can see if you have a double bond, in that case you still need to prioritize the carbonyl groups. So you can see the double bond is located at carbon number 2, so it's the 2-propanol. Okay, propanol. The 2 is to signify the location of the double bond. The 2 you can do that prop 2 enol. Okay, that's fine as well. I won't penalize you, yeah. When you're looking at the ketones, okay, the ketones, as you can see that the locations of the carbonyl groups is somewhere in the middle of the molecule. All right. In that case, you need to prioritize, okay, the carbonyl group. Same thing. So what you need to do over here, right, is you need to find the closest. Okay, you need to number in such a way that you need to have the smallest number for the location for the carbonyl groups here. So you can go from left to right, 1, 2, 3, 4, 5, 6. Okay, so look at carbon 3 if you calculate from left to right. If you go from right to left, 1, 2, 3, 4, 5, 6. Okay, so the smallest one is go from left to right. Again, number 3. So you can see here the location 1, 2, 3, 4, 5. The methyl group is located at carbon number 5, so 5-methyl 3-hexanol. Some of the common the aldehyde and ketones we have like formaldehydes, acetaldehyde, propanaldehyde, acetones, methyl ethyl ketones. Yeah, all these are what we call common names. Okay, the IUPAC name is more internationally standardized. Okay, but you can still hear a lot of all these formaldehydes, acetone. Formaldehyde is what you use it for preservations, whereas for the acetone, use very common solvent that you use in the nail polisher. Okay, also is very good solvent for anything that to dissolve. But the IUPAC name is propanol. All right. So just to practice, okay, so name the following aldehyde according to IUPAC name. All right. So for these are the aldehydes, so you go from right to left, 1, 2, 3, 4. So this one is butanal, okay, butanal. You do not need to write the 1 because aldehydes is located at carbon, the last carbon, so it will be designated as carbon number 1. So same thing here, 1, 2, 3, 4. So the bromine located at number 3, so it will be 3 bromobutanal. Over here, 1, 2, 3, 4, 1, 2, 3, 4. So the longest is 4. You can go either left or right, no worries. Go to right hand, 1, 2, 3, 4. The appendix group located at carbon number 2, so it's 2-ethyl butanal. Okay. Whereas for the ketones, okay, ketones over here 1, 2, 3, so it's propanal. You do not need to write the number 2. The reason is that there's only 3 carbons, and the ketones, it needs to be in the middle. The carbonyl needs to be in the middle of molecule, so there's only 1 location. So not necessary to write the 2 in your IUPAC naming. Yeah. Whereas this one you need to find the smallest number. So you go from left to right, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it's shortest from left to right. So carbon number 2. So in this case, 1, 2, 3, 4, 5. Okay. The methyl group located at number 3. So it's going to be 3 methyl, 2 pentyl. Okay, let's look at the physical property of aldehyde and ketones. Okay, when we talk about physical properties, we talk about the boiling point, the melting point, solubility, and so forth. Yeah, and this physical property is due to, okay, as similar as previous chapters, you're looking at intermolecular force, which is the interaction between molecules, right? So first of all, you need to find out what is the interactions that is available for the intermolecular force. Yeah. So let's first look at the physical property of aldehyde and ketones. Okay. For example, the interaction between aldehyde and aldehyde. Okay, or ketone and ketones. So first, you need to find out what is the functional groups, the carbonyl groups, sort of the characteristics. In this case, right, you can see that the carbon and the oxygens, they are actually a polar covalent bonds. Okay, polar covalent bonds are being with this characteristic that they are slightly positive and slightly negative here because of the unequal sharing of the electrons. So there are more electrons at the oxygen compared to the carbons. Because of this, it makes the carbonyl groups polar. So it actually facilitates the interaction between molecules. Okay, the oxygen, you can actually molecule the delta positive. Okay, and the oxygens have an interaction between this one, the negative and the positive. And this interaction is what we call dipole force. Okay, dipole force is strong, but is not as strong as hydrogen bonding. Okay, so you can see from here there's no H and O or N and H and so forth. So this is not a hydrogen bonding. This one is called dipole. The interaction is weaker compared to hydrogen bonding. Yeah, but this dipole force is stronger compared to dispersion force. That's why if you go to see here, comparing between this molecule, actually you compare this here. This over here increasing the boiling point is due to the length of the hydrogen, okay, which is due to the dispersion force. Okay, so you look at this. Okay, so this one is due to this is because it's dipole. This is hydrogen bonding. This one is dispersion force. Okay, this is looking at the interaction between molecule and molecule, how they interact. For this one, okay, the alkenes, the molecule interact through dispersion force. For aldehyde and aldehyde, they interact through dipole double force. For the alcohol, they interact through hydrogen bonding. Okay. Now, let's change the target. Instead of aldehyde and aldehyde, how about interaction between aldehyde and water molecule? If you're looking at the interactions, they actually is, okay, because an O and H is the hydrogen bonding. So they interacted through hydrogen bonding. Because of that, they makes the aldehyde soluble in water. Okay, that is also one of the reasons why carbohydrates are soluble in water, because the carbonyl groups can interact with water molecules. All right. Okay. Next, let's look at the key reactions of aldehyde and ketones. What we have here is the functional groups, carbonyl groups. Carbonyl groups are reactive. Okay, it's reactive because of the dipole force. Okay, because of the delta positive, delta negative, it makes the carbonyl group reactive. But when you talk about the reactivity comparing between aldehyde and ketones, aldehydes has more reactivity compared to ketones. The reason is because of the location of the carbonyl groups. The aldehyde is located, carbonyl group is located at the end of the molecules, so it's more accessible compared to carbonyl group located somewhere in the molecules. This is exactly same concept that we have described for primary alcohol, secondary alcohol, and tertiary alcohol. Okay, the accessibility of the functional group for reactions. So you can see from here, okay, if you look at here, it's 2-carboxylic acid, but if you're looking at the aldehyde, it actually can be formed through oxidation of primary alcohol. Okay, so we have sort of like mentioned that in the previous part. All right. If you're looking at the ketones can be oxidized from the secondary alcohols, but if you're looking at that, it cannot be further oxidized to form carboxylic acid, because carboxylic acid, if you're looking at aldehyde, okay, carboxylic acids, the functional groups need to be at the end of the molecules. That doesn't apply to ketones. Ketones doesn't have their carbonyl groups located at the end of the molecules. Okay. So when you're looking at the reduction reaction of aldehyde and ketones, it can be done through hydrogenation process. Yeah, this is exactly the same hydrogen process that we have mentioned previously. For example, the alkenes can be hydrogenated, the alkanes. Yeah, so basically the double bond has been reduced by the hydrogen gas to form alkanes. Alright, of course, it will need to have in the presence of the metal catalyst here. So you can look at this. The aldehyde can be reduced through hydrogenation process through primary alcohol, whereas the ketone can be reduced to a secondary alcohol. And this is basically a very critical important reactions, because commonly the sugars has been reduced to form what we call sugar alcohol, which is the low calorie sweeteners here. Okay, the next one, right, is very, very important. We're going to describe about important reactions between alcohol and aldehyde. Previously, we are talking about conversion from primary alcohol to aldehyde or secondary alcohol to ketones. But now we are talking about the reactions between alcohol and the aldehyde. Okay, more specifically, you're talking about the reaction between a carbonyl group and a hydroxyl group. So the reaction we talk about here is a separate. Okay, the functional groups is located as separate molecules. When they react, they form what we call a hemiacetal. This molecule, okay, because of the it was reacted from two different molecules, this hemiacetal form is unstable. it will require to react with more alcohol to form a stable acetal. Okay, stable acetal. Same go to ketones. Okay, when this reaction between ketone and the alcohol. Okay, this alcohol doesn't need to be a secondary alcohol here. The ketone and alcohol, particularly talking about the reaction between the hydroxyl groups and the carbonyl groups, it will form what we call a hemiketal, but this is unstable. Okay, which require to react more with more hydroxyl groups, okay, of the alcohol to form a stable ketone. Alright. It's very important for you to know how to practice to identify. Like for example, in these questions, we are talking about looking at this, identify this molecule. Okay, whether is it a hemiacetal, hemiketal, acetal, or ketal. So it's basically asking you to look at this, whether is it this one, is it this one, okay, is it this one, okay. So you need to look at the features. So over here is best you look at, and then this one is a OR, is a hydroxyl group over here. So you basically, when you see the hydrogen here, okay, this one is at the end of the molecule. So more or less you can say that this one is the aldehyde. Okay, so let's look at this. You only got one OR, so this one will be a aldehyde that has been undergo the reaction with alcohol once to form a unstable hemiacetal. Okay, we have a OR, okay, and OR prime, and this one is that's located somewhere in the middle. So this one is a ketone. Okay, this ketone reacted twice, okay, with the alcohol group to form a ketal. Okay, to form a ketal. Okay, so this one, please make sure you practice. Okay, because exam frequently come out. Yeah. So as a summary, what we have is the aldehyde ketones. Okay, can be reacted, oxidized to form carboxylic acid. Whereas ketone you cannot further oxidize. Okay, but you can reduce. Aldehyde can be reduced to primary alcohol, and the ketone can be reduced to secondary alcohol. Then we have mentioned about these hemi formations. Okay, if it's an aldehyde reacted with an alcohol, they will form a hemi further to form a stable acetal. Whereas for ketone, we can react with alcohol to form a hemiketal. Okay, it's unstable and required to react more alcohol to form a stable ketal. Okay. Okay, let's look at some of the common molecules of aldehyde and ketones. We have formaldehydes. Okay, is frequently used to preserve or sterilize the equipments previously, and use it to kill bacteria. Yeah. Acetones, as I mentioned, is a very useful solvent. Okay. What happened is that it has been widely used to dissolve like paints, as well as to use it as one of the solvent for the nail polish remover. Yeah. Okay, so basically, ladies, you like to polish your nail, to paint your nail. Okay, then if you want to remove it, you can use the acetone to remove it. Yeah. Then it has some other molecules as well, vanillins, okay, semialdehydes, citrals, biacetals, camphor, menthol. Okay, all these you can see that they have contains the or in this case, okay, ketones, okay, and ketones. Yeah, so you can see carbonyl groups are in these molecules. Yeah.